Hi, this is Ms. Fitzmaurice, and this video is an explanation of the fourth phase response problem. So that's on page 7 of your review packet. So in this problem, we have a pulley system. So here's our pulley system, and we know the masses of each block. We have a 1 kilogram block, a 2 kilogram block, and a 4 kilogram block. Okay, as you would expect, since on the left-hand side there's only 3 kilograms, and on the right-hand side there's 4 kilograms, the acceleration of our whole system has to be down this way. Okay, so in part A, it wants us to calculate the acceleration of the 4 kilogram block. Now, to calculate the acceleration, we have to use this whole system. Okay, so just a quick refresher, if you are doing Newton's second law with a system, then you have to draw a combined force body diagram. Okay, and what I'm going to do is I'm going to draw the forces and only the outside forces, so I'm not going to count any of the tensions acting on my system. So I have FG, I'm going to call that FG4 going this way, FG3 going this way, and I have FG2 going this way, and I'm actually going to rename this one down here FG1 because it's 1 kilogram. Now, to put this all on one force body diagram, we're going to unwrap the pulley so that FG4 points straight up. So we're unwrapping it this way. And when we do that, this is our force body diagram. So FG4 is pointing upwards, and FG1 and FG2 are pointing downwards. Okay, then we write out Newton's second law. So sigma Fy is equal to MAy. We know that the combined mass, 1 plus 2 plus 4, has to be 7. And each Fg will just be 10 times whatever mass we have. So we have Fg4 minus Fg1 minus Fg2, and so that's 40 minus 10 minus 20 is equal to 7 AY. Okay, we can solve for AY, and we end up with 1.42 meters per second squared. Okay, next in part B, we want to know the tension in the string supporting the 4 kilogram block. So, because tension Ft is an internal force, we have to draw the force body diagram on the individual object, so on F4 only. So we draw that force body diagram. We have Ft pulling up, and we have Fg4 going down, and we're solving for this Ft right here. Okay. One thing we have to keep in mind is that since the net acceleration is down, okay, what that means is our acceleration that we found in part A is really negative. Okay, so we have sigma Fy equals MAY, Ft minus Fg4 equals MAY, and remember, it's just the 4 kilogram object that our force body diagram is of, so our mass is only 4, and then negative 1.42. Okay, we know, of course, that Fg of 4 has to be 40 newtons, so we have Ft minus 40 equals negative 4 point, actually, excuse me, not 4, negative 5.7 about, so negative 5.7 and of course we're adding 40, so we end up with Ft is equal to 33.3 newtons. Now in part C, we want the tension of the string on the 1 kilogram block. Okay, so here's my 1 kilogram block. Of course, we have tension going up and gravity going down. And we know that our acceleration on the other side of the pulley is positive. Okay, so our acceleration is going to be 1.42. And it's just going to be positive 1.42 meters per second. So sigma Fy, all the forces in the up-down direction, equals MAY. Ft minus Fg equals MAY. The mass in this case is just 1 for our 1 kilogram object times 1.42. So we have F tension minus Fg, which is 10, is equal to 1.42, and Ft is equal to 11.42 newtons. Alright, so in terms of points, if you drew a force body diagram that looks like this, give yourself, 2 points. Okay, if you were missing one force or had one extra force, take off a point. If you wrote Fy equals MAY and you put in Fg4 minus Fg1 minus Fg2 equals 7AY, in particular, you're following your force body diagram and you have this 7, the total mass. Give yourself 1 point and then give yourself 1 point for this answer of 1.42. In part B, give yourself 1 point for this force body diagram. Give yourself 1 point for following it and only using the 4 kilograms as your mass. Okay, so like this line right here, this is 1 point, and then 1 more point for the final answer. Okay, again in part C, you get 1 point for the correct force body diagram, 1 point for this line. Specifically, if you use, 1 as your acceleration, and 1 as your mass, and the acceleration that you got in part A, whether or not that acceleration is correct, and 1 point for the final answer.